Final thing that we're going to look at here in the carbohydrate chapter are reducing sugars. And this is an important concept not only for historical healthcare related assays to detect glucose in the urine basically, but also an important chemical distinction between carbohydrate units. And when we talk about a reducing sugar, a reduction is a type of reaction. And so what we're really talking about is a sugar that is unlocked. It can be added to another structure easily. It hasn't really used up all of its reactive sites. And different sugars are either reducing or non-reducing. Sucrose is not reducing, and we'll take a look in a second on why that is. Before it could become something more active, it has to be broken down. Of course, when we look at monomers, these are all reducing sugars because they need to be added to other structures easily. So glucose, galactose, and fructose are all reducing sugars. And the starred carbon here is where they're going to react. Take a careful look at this carbon and see what it's connected to and why. And what you'll notice is that it's connected to oxygens on 2 of the carbon's 4 bonds. This is key to why this carbon is a reacting carbon and why the sugar that it's present on is a reducing sugar. Here we have glucose with its active carbon marked with a star. This is where glucose is going to react and form a larger carbohydrate. And let's look at maltose and sucrose and try to determine which of these two is a reducing sugar, which is to say which of them has a carbon that's really in a similar identity to the glucose carbon marked with a star. Take a minute and pause here and see if you can determine that, and then I'll continue forward. Alright, this was somewhat given away from the previous slide, but if we look at these, what we can determine is that maltose is the reducing sugar and is so because of this site on maltose that we've marked with a star. It's this carbon that's actually bonded to 2 oxygens, right? And that's key to where we have a reducing sugar, is that the carbon where the reaction occurs is bonded to 2 oxygens and can't already have a glycosidic linkage. So there is another carbon similar on the other side, but it's part of a glycosidic linkage. And what we'll notice is that sucrose does not have this site available at all because of its structure and how it's made with different monomer units. This is to say that sucrose, before it could be added to anything else, needs to be broken down into something that is a reducing sugar. And previously, an archaic test, I would say, for years this was used in hospitals, but it's really not anymore. We use Benedict's reagent to observe color change in the urine sample. And this has a positively charged ion in it that is going to change color based on the presence of reducing sugars in the mixture. And so pretty much what we're testing for here is glucose, where if someone has glucose in their urine, that's indicative of the fact that glucose isn't being broken down properly, which could indicate a variety of ailments. And so this was previously what we did. You set up a test tube and you measure the color and you see what it looks like. But more modernly, healthcare uses glucose oxidase test strips, dipsticks, where we pretty much just have a strip which we can dip into urine and it'll give you a reading right away. This can be done bedside. And again, while the primary test is for glucose in urine, it can test for a variety of other things, and if there is glucose in the urine, that could indicate signs of diabetes, that the insulin is not working properly to grab all the glucose, or kidney impairment or other health effects. Knowing if there's glucose in the urine is a really important part of healthcare, right? That's a really big marker of something that's an easy test to do.